Hey everybody. So I wanted to talk to you with a little introduction to chemistry. And so you may be asking, well, why am I sitting out here in my backyard with the fire going and competing with the sounds of nature and the smoke and everything like that? Well, I could do this in a lab, in a classroom, behind my desk, or in the little recording video studio I have set up in my basement. But one of the things I think about chemistry, and that when people come into my class, is that, what they know about chemistry usually is that they think it's going to be really hard, and that it doesn't make any sense, and it's not anything that has anything to do with their day-to-day lives. And I'm not going to say some of this isn't going to be hard. There's challenging stuff, right? Even for me, been doing this a long time, there's stuff that's still challenging. Doesn't mean we can't do it. And it's definitely not something that has nothing to do with your everyday life. For example, right here in front of me, right, we have this fire going, which I think probably we all understand is a chemical reaction. It's called combustion. And even if you don't know exactly what's going on, there is a reaction taking place between the oxygen in the air and the molecules that are in the wood, and they're releasing heat, and they're releasing this light, which all has to do with atoms and molecules moving around and getting heated up and excited and releasing energy. The energy that's the heat that we feel comes from chemical bonds being broken and new chemical bonds being formed. The matter that's in the wood is changing from the wood into something else. And first, chemistry. Okay, the definition of chemistry, which we'll get into details, and I'll have you write some of this stuff down later, but chemistry is the study of matter and the changes that matter can undergo. Okay, the study of matter and the changes that matter can undergo. Those could be physical changes like melting of ice. They could be chemical changes like combustion. They can be nuclear reactions, which I'm going to talk about in a minute. But the fact is, they're everywhere. The stuff that we're talking about, matter. Matter is anything that has volume, which means takes up space, and has mass. That's pretty much everything in the universe is made of matter, and atoms, and molecules, and little tiny particles that make up atoms. Okay? So we're studying everything. It could be anything. And they can go through all these almost unlimited number of types of changes that you can think of. There's one going on right now with the burning. There's also the heating of the air around us, which is a physical change. The molecules in the air are moving faster and faster because they're getting heated up. There's also other stuff, right? Again, something that most of us are familiar with. If I put the marshmallow into the flame, first of all, it's going to get heated up, which that's a physical process. It's absorbing energy from the fire. And then if I leave it in there long enough, we know what happens, right? It'll start to turn black. And that's because now there's a chemical reaction happening in which the sugar in the marshmallow is undergoing a change because of the heat. Okay? So once you burn a marshmallow, right, you have a chemical change. Well, you don't get the marshmallow back once it's burned. You got to start over. Okay? So depending on how you like your marshmallow or your s'mores, all right, you want to wait until it gets to a certain point, and then you let it go, throw on some chocolate, some graham cracker. I'm not going to make you watch me eat this, I promise. But here's again a physical change. Now the heat from the marshmallow is going to start to melt the chocolate. The melting is a physical change, right? It's not that the chocolate is turning into some other stuff. The chocolate's just turning from solid to liquid. And then if I did take a bite of this, first I would break it apart with my mouth. That's a physical change. It's matter undergoing change. And then it would start to dissolve in my mouth, and I'd swallow it and go to my stomach, and it'd digest, and that's a chemical process, which leads to other chemical processes in my body that keeps me going. All right, we breathe the air. The oxygen in the air undergoes chemical reactions in our body. Not that different from what you're seeing in the fire in front of me. It's combustion. Oxygen reacting with other chemicals and other compounds. Okay, it's just that in our body it's really, really tiny, and it's really, really slow, and that's what keeps us going. Also, again, to look at the wood, I mentioned nuclear reactions. So this wood, which comes from a big elm tree that fell down in my yard in the past few months, has a lot of carbon in it, just like we do, like every living thing on Earth. Well, carbon, the atoms of carbon, come in different varieties called isotopes. And we'll talk about those a little bit later on. But they're atoms of carbon, they're all carbon atoms, and they have different particles called neutrons. Some have 6 neutrons, some have 7, some have 8. Well, the ones that have 8 are called carbon-14. And anywhere you've got carbon-14, even inside our bodies. That carbon-14 is radioactive. It decays over time. It breaks apart. So yeah, even inside our body, chemical carbon atoms are breaking apart and forming new atoms. Well, the carbon in this wood, because it's dead, right? The tree fell down. Well, the number of carbon atoms in this wood is slowly changing because of that radioactive decay. Now, in our bodies, we're constantly replacing the carbon atoms because we eat and we breathe and we get new carbon atoms to replace the ones that decay. But not in this wood. This wood isn't taking any more water, it's not taking in any more air, it's not living. So the number of carbon atoms is starting to change very slowly. And there's something that's a radioactive, a nuclear decay process. And we know exactly how long it takes for a certain amount of carbon to decay. So if I were to put this into a time capsule, or if I took the charcoal that's left at the end of this fire and I buried it and it sort of sustained itself, well, 10 or 20,000 years in the future, if someone found this piece of wood, they would be able to measure the amount of carbon in here and approximately determine that it came from around the year 2020. Okay, not exactly, but pretty close. Okay, so that's chemistry. It's going on right now. This piece of wood is undergoing radioactive decay. Not something that's dangerous to us, but it's really, really slow, and it's happening right now. Other things that happen, right? If I take certain chemicals, and this is again a little bit of chemistry that we've all probably seen, right? Most of us at one time or another have seen fireworks, right? All different colors. Well, those fireworks take advantage of the fact that different chemicals, different atoms and molecules release energy in light in different wavelengths. And I hope this is showing up okay. Okay, so you can see now that the fire, it's not just the yellow and orange that we're kind of used to. There's some blues and greens in there. And that's because of the stuff that I put into the fire. And that's how fireworks are made different colors. They use different types of elements, right? Elements and atoms and molecules and stuff we're all going to talk about. So, yeah, we're going to do some stuff in a lab hopefully this year. But I just want you to understand that chemistry is absolutely everywhere. Okay? And we see it, and we are doing it inside our bodies and all around us every single day. Okay, so it's not, some of it is going to be abstract and stuff that we can't really see, because we're going to talk about atoms that we can't see what an atom really looks like. But this is chemistry going on right here, and it's something that we can all see, and it's the result of stuff that's happening between atoms and molecules that we can't see. Okay, so we can observe chemistry even if sometimes we can't see all the exact details of what's going on. So I just wanted to kind of make that introduction, because I do think that a lot of people walk into chemistry class thinking, I have no idea what this is about and it doesn't really matter to me. I think it does. It's pretty much everywhere around us, and it's good to just have an understanding. Even if you don't become go through any kind of career that involves chemistry, although that might be pretty hard to do when you think about it. But if you're not focused on the science of chemistry or medicine or materials and things like that really, really get into the chemistry, it's just good to know what's going on around you. That's what science is all about. All right, we'll see you soon.